Good morning, students. Welcome to the course Retrofitting and Rehabilitation of Structures PE821 CE. Today, we'll continue with the third unit, Condition Assessment, Non-Destructive Testing and Evaluation. This will be the third lecture on this unit. We will be discussing partially destructive tests. We will be discussing testing methods for mechanical properties. There are two types of testing methods for mechanical properties of concrete. One is partially destructive tests and other one is non-destructive tests. Yeah, partially destructive tests and non-destructive tests. So these are the summary of the testing methods. This classification we have already discussed. So compressive strength, they are different tests. Quality of concrete, they are different tests. Tensile strength, different tests. Flexural strength, abrasion resistant, bond strength, so on. So some of them are destructive, that is, some of them are fully destructive, some of them are partially destructive, and some of them are non-destructive. So our focus will be on discussing partially destructive tests. Although we will just look into few aspects of non-destructive tests. Yeah, see here. So for compressive strength, partially destructive tests are core cutting and testing, Windsor probe test, pull-out test, and non-destructive test for compressive strength is rebound hammer. Ultrasonic pulse velocity test is also an indirect measure of compressive strength, but not directly. For quality of concrete, means its uniformity, homogeneity. Uh, a good test is ultrasonic pulse velocity test. Then for tensile strength, pull-off test and split tensile test. Split tensile test is a totally destructive test. When we say DT, it is destructive. When we say PDT, it is partially destructive. And when we say NDT, it is non-destructive test. So for flexural strength, we have destructive test, center point load and 3-point load test, and then for abrasion resistance, sandblasting test, and for bond strength, pull-off test. So in this particular lecture, we will be focusing on partially destructive tests, and we will not consider other tests, and even in partially destructive tests we will not consider sandblasting tests. So these are some of the partially destructive tests that will be discussed in this particular lecture. Core extraction and testing, pull-out tests, which are of two categories, lock test and capo test. Capo test means cut and pull out. Next is pull-off test, and then Windsor probe test. Partially destructive test. So core first one of the partially destructive test for identifying mechanical properties of concrete is core extraction and testing. So concrete cores are usually cut by means of a rotary cutting tool with diamond bits like this. There's a handheld drilling bit, and there are machine held drilling bits also. So a cylindrical specimen is obtained, usually with its ends being uneven, parallel, square, and sometimes with embedded pieces of reinforcement. The core should then be soaked in water, capped with molten sulfur to make its ends plane, parallel, at right angles, and then tested in compression in a moist condition as per either British Standard 1881 Part 4 1970 or ASTM C4277. So these are examples of core extraction. This is not a handheld but a machine held wall mounted. Uh, there's a wall mounted frame which holds the drilling bit. Through that one can drill. This is handheld drill bit. Through either of these methods you can extract cores like this. Naturally, this is a destructive test, and we call it partially destructive because it is not damaging the whole structure. Now, for core extraction, we need to be careful how we extract the cores. The strength of concrete core test specimen depends on its shape, proportion, and size. The height to diameter ratio influences the recorded strength of cylinder. So this height to diameter ratio is a very important consideration in extraction of core. Strength of core have to be related to the standard cylinder strengths. For example, for height to diameter ratio of 2, okay, the core should be preferably have this ratio nearing 2. So the standard cylinder's height to diameter ratio is 2. So the core extracted should be having nearly the same height to diameter ratio, which may not be possible in each and every case. For values of height to diameter less than 1, between 1 and 2, a correction factor has to be applied. Cores with height to diameter ratio less than 1 yield unreliable results. And British Standard 1881 Part 4 1970 prescribes a minimum value of height to diameter ratio as 0.95. Now, the same standards specify the use of 150 mm or 100 mm cores. However, cores as small as 50 mm are also permitted in the standards. Now, factors affecting the strength of cores. The following factors affect the compressive strength of the extracted cores. First, size of stone aggregate. The general rule adopted for fixing the core size, besides height to diameter ratio, is nominal size of the core aggregate, and the diameter should be not less than 3 times the maximum size of the stone aggregate. For diameter of cores less than 3 times the size of stone aggregate, an increased number of cores have to be tested. So, if the maximum aggregate size in that has been used in the concrete is X, then the diameter of the core should be at least 3x. If it is less than 3x, then it will produce inaccurate results. We need to take more number of cores. Presence of transverse reinforcement. It is reported that the presence of transverse steel causes 5 to 15% reduction in compressive strength of cores. The effect of embedded steel is higher on stronger concrete and as its location moves away from the end, that is towards the middle. However, presence of steel parallel to the axis of the core is not desirable. So, best is to avoid steel reinforcement. There are methods such as profometer which can detect where the rebars are located. Wherever rebars are not located, from that core can be extracted if possible. However, sometimes if core has to cut the steel, then it has to be in transverse mode. It cannot be parallel to the axis of the core. So, height to diameter ratio already discussed, minimum 0.95, maximum 2. Higher ratio would cause reduction in strength. Next, strength of concrete. The effect in reducing the core strength appears to be higher in stronger concretes, and reduction has been reported as 15% for 40 MPa concrete. However, reduction of 5 to 7% is considered reasonable. So this is quite natural because say the core, the when we test the concrete samples directly at the time of casting, we make concrete cubes and then we test. That gives the concrete characteristic strength. However, naturally the cores will have lesser strength compared to the original concrete. The reasons are multiple. Concrete may degrade. Even concrete doesn't degrade. The core drilling itself causes such vibration that the strength of the concrete will degrade. So, then drilling operations, the strength of core is generally less than that of standard cylinders, partly as a consequence of disturbance due to vibration during drilling operations. Site conditions versus standard specimens. Because site curing is invariably inferior to curing prescribed for standard specimens, the in situ core strength is invariably lower than the standard specimens taken and tested during concrete operations. So that was about core. So in core, once the core is extracted, you do tests such as put it in a compressor testing machine and test and find the compressive strength, or we can do the split tensile test and accordingly find the value of the tensile strength of the concrete. So this is a standard way of examining the strength of concrete using cores. Next is pull-out tests. Pull-out tests are of two types. One is lock test, other is capo test. Capo is cut and pull-out test. Lock test and capo test, they differ upon the method of placement of the disc or ring in the fresh concrete. We'll just see what it is. See, this is lock test. In this, see, this is a piece of element. This is like this is a ring of 25 mm dia and a thin bar through the central axis of the ring of this length is 25 mm, and of course this protrudes out. So this is a piece. So this is a steel disc attached like this. So for conducting a lock test, while the concrete is being casted, this piece has to be embedded in the casting. Okay, so concrete has to be poured around it and concrete naturally hardens around this. So this piece, the pull-out test piece, is embedded in the concrete at the time of casting. That is lock test. So lock test system is used to obtain a reliable estimate of in-place strength of concrete in newly cast structures in accordance with the pull-out test method described in ASTM C900 BS 1881207 or Eurocode 125043. So a steel disc 25 mm in diameter at a depth 25 mm is pulled centrally against a 55 mm diameter counter pressure ring bearing on the surface. So once this piece is put and this protrusion is comes out, then we place another ring of 55 mm dia, and there is a hydraulic mechanism equipment which is used to pull this out with force. The force F required to pull out the insert is measured. The concrete in the strut between the disc and the counter pressure ring is subjected to a compressive load. Therefore, the pull-out force F is related directly to the compressive strength. So now you can see this. Here in between these two, this is a ring here and this is the inside disc. So when this is being pulled, naturally concrete here is subjected to compression. So, and this crushes the concrete here and comes out. So you get a compressive strength. Another version of lock test is the capo test. Capo test is cut and pull out test. In capo test, you do not have to put that insert piece at the time of casting. You can do it after the concrete is casted. So capo test gives a greater flexibility than the lock test in this regard. The capo test permits performing pull-out tests on existing structures without the need of pre-installed inserts. Capo test provides a pull-out test system similar to lock test system for accurate on-site estimates of compressive strength. Procedures for performing post-installed pull-out tests such as capo test are included in ASTM C900 and Eurocode 12504. So here is the description of the capo test. What happens is, first, for the concrete structure, first a hole is drilled. We drill a hole up to 25 centimeter with this diameter, a small diameter. This is then after this there is another drill bit that is sent, which expands, the blade expands, and the drill bit cuts this dimension. Okay. And there is a greater diameter of 25 mm, that is 25 mm diameter. Now this piece, the steel disc piece, is a split ring which is expandable. So while it is inserted, it will go through this smaller diameter, but once it crosses here, it expands to 25 mm diameter. So that is how it is similar to lock test, but only difference is in capo test, this piece is inserted after the casting is done. So everything else remains the same. This dimension of 25 mm, this diameter of 25 mm, this outer ring of 55 mm, everything remains the same. Capo test. Now for both capo tests and for lock tests, they are, once you pull out, you have pull off tensile stress versus the cube compressive strength. Okay, and you have the pull out forces on this axis and the concrete compressive strength on y axis. They are standards, and based on your strength, you can cross check based on the pull out value. You can gauge the concrete compressive strength. So these are charts that are used. Now pull out tests are used to determine the in situ compressive strength of the concrete, ascertain the strength of the concrete for carrying out post tensioning operations, determine the time of removal of foams and shore based on actual in situ strength of the structure, terminate curing based on in situ strength of the structure. So these are some applications of pull-out tests. After the concrete has fractured by this test, the holes left in the surface are first cleaned with dust by a blower, cleaned off the dust by the blower. It is then primed with epoxy glue, and the hole is filled with polymer modified mortar immediately thereafter, and the surface is smooth. So we have induced a damage in the concrete structure. So this is a remedial measure to fill. Next test is pull off test. Okay, I'll skip this part, you can read it later, but I'll go directly to the methodology. So pull off test, it conforms to BS 1881 part, British Standard 1881 part 207. Now it gives direct, pull off test gives direct tensile strength value by tensile fracture. The test may be carried out by partial coring of the concrete and bonding a metal block on the same nominal diameter to the top of the cylinder of the concrete, thus isolated. This allows the fracture to occur deeper into the concrete. Metal block is pulled off from concrete surface with hydraulic jack and tensile strength, and If the test is carried out after partial coring, reinforcing steel should neither lie within the annulus nor within the depth equal to maximum aggregate size of the base of the annulus. 6 valid tests are usually sufficient in each location. So now this is the pull-off test. In pull-off test, first what is done is a portion of the concrete is just drilled. That means there's a hole in a cylindrical portion here. Now so this is, we have drilled and cut. Now we put a, a piece here, metallic piece, and we bond this metallic piece very strongly with epoxy and resin. Now this bond becomes very strong, much stronger than the concrete bonding. Now this, with a hydraulic jack, this arrangement is pulled out. When it is pulling off like this, then naturally a direct tensile stress is developed and a tensile fracture takes place. So here it is showing through hydraulic jack, and this concrete, it is tensile fracture plane. This is the fracture plane and it is cut. So possible failure surfaces, one is this, other is an inclined. If it is a shear induced failure, it will be this, but primarily it will be a tensile induced failure. Now there are correlations. Correlation between the tensile strength thus obtained versus the compressive strength of the concrete. So there is a correlation. For example, 25 kg per centimeter square will lead to 30 kg per centimeter square strength. We can of course convert to SI units and see, but this is taken from, these slides are taken from NPTEL course, which in turn they have taken from researchers of Japan. So there are 4 cases of 4 different researchers who did research and plotted the relationship between tensile strength through pull-off test and the compressive strength. Last one is the Windsor probe test. Now Windsor probe test is a penetration resistance test on hardened concrete. Penetration resistance test is conducted on concrete structures using Windsor probe test machine. In this test, a steel probe is fired on the concrete surface by a sudden explosion, like a bullet through a gunshot. The penetration is inversely proportional to the strength of the concrete. The result of the test is influenced by aggregate strength and nature of formed surfaces of concrete. Now the main purpose of the penetration resistance test or the Windsor probe test is to determine uniformity in concrete, specify exact location of poor quality and deteriorated concrete zones, assess in-place strength of concrete. So Windsor probe, it is like this gun, and this is the Windsor probe. You shoot and this probe gets driven into the concrete with a force. So this probe is manufactured from alloy, steel alloy, plated for corrosion protection with a blunt conical end. So here is the probes, here is the gun, here is the depth of penetration of the probe measuring device. So the Windsor probe gun is put to the concrete wall and it is shot, so the probe gets inserted. Once the probe gets inserted, you have another mechanism of putting a cap around the probe and then measuring the length of the probe that is protruding out of the concrete. So there are beautiful videos on this, you can watch later. Now how to position? There are positioning devices so that the gun is properly placed. So there is a single device or a triangular device. This picture shows a triangular device. So here two probes are already punched. Here the third one is being shot. Now sampling of the uh, how many samples of the probes we have to take. Concrete to be tested should have gained enough strength so that probe would not penetrate more than half the thickness of the concrete member. So it has to be a hardened concrete. It cannot be early stages of curing. Next, maximum spacing between the probes is 175 mm. Minimum spacing between the probes is 100 mm. Minimum spacing between probe and the edge of the concrete surface is 100 mm. A minimum of 3 firmly embedded test probes in a given test area constitutes one test. So, testing procedure, which I've already explained, while you can go through. Now, testing considerations. So, this is the probe that has penetrated. This is the damage zone. These are the cement matrix here, the concrete matrix. Now, if the probe is sloped with respect to the surface of the concrete, take 4 measurements equally spaced around and parallel to the probe and average them to get the measurement. Generally, the probe should penetrate perpendicular. If it is inclined in any way, then we have not got the proper reading. The test was not accurately performed, or there must have been a obstruction here of a very strong aggregate or something like that. So if the probe is not firmly embedded, then the test is not valid and hence it should be repeated. Similarly, the test should be repeated if the range of depth of penetration for 3 tests is more than 8.4 mm in concrete made with 25 mm maximum aggregate grade and 11.7 mm in concrete made with 50 mm maximum aggregate size. Okay, so these are some considerations with Windsor probe test. And then we have results relating to penetration depth calculation. The depth of penetration, uh, now penetration depth versus strength. So naturally, greater the penetration, lesser will be the compressive strength. So that's how a chart is made according to ACI standards, and we measure the concrete compressive strength. So Windsor probe test is also a partially destructive test, but it is a superficial. All these tests have superficial damages on the surface. So the lecture material for today's lecture has been taken from these books: Handbook on Repair and Rehabilitation of RCC Buildings by published by CPWD, which we have been using. Then we have Concrete Repair and Maintenance illustrated by Peter H. Emmons, and some portions of Guidebook on Non-Destructive Testing of Concrete. They are very good web resources. I encourage the students to go to these web resources. This is a full lecture, of course. First one is a full lecture uh, by Dr. Sudhir Mishra of IIT Kanpur. So you can go through this. It gives some good insight. Now these are concrete core cutting. They have good videos of concrete core cutting. Other than these sites, you can go to further sites, but I have selected some sites which I thought will be useful for students. Then these are for pull-out tests, the methods that are used. This is for lock test particularly, this is for capo test, and this is the pull-off test procedure, and then Windsor probe test procedures. Thank you. With this, we come to the end of this lecture. Thank you.